Hello everyone, welcome to today's lecture. In our previous lecture, we have seen that there are mainly two types of routing algorithm. First is a static, which is called non-adaptive routing algorithms, and second is dynamic, which is also called adaptive routing algorithms. So let's start with the first static routing algorithms. So a static or a non-adaptive routing algorithms. As the name suggests, static means it cannot be changed. It cannot change. Non-adaptive, it means it cannot accept the change based on the situation. So that is called the static or the non-adaptive routing algorithms. So these are the algorithms which do not change their routing decisions once they has been selected. So in this algorithm, first we are manually adding the destination route. We are manually adding each of the routes on the routing tables, and that is given to the algorithms. So they only follows that rules. They cannot change the rule once the routing decision can be selected. So this is also known as a static routing, as route to be taken is computed in advance and downloaded to the routers when router is booted. So we already given the multiple paths to the this algorithm. Yes, so when router is rebooted, then it automatically choose the that static routes by default. So it is already taken their path in advance, so they cannot change further. So if in network, if traffic occurs, it cannot change the route. So static routing is suitable for a small network. Static routing becomes burden on some bigger networks, and route of each destination network has to be manually configured by the network administrator. So we have to write the whole path from source to destination manually, and that is done via a network administrator. So that is a burden for any big network. So if you have a big network, so for each and every device you need to add the routing paths. So that is a burden for any network administrator. So that is why it is used only when the network configuration is very small, such as if administrative distance is equals to 1. Now next is routers can be entered by the network administrator who configures the route manually. Since this manually configured route doesn't change after they configure, they are called static routers. As I already said that because we can change anything in this route, that is why it is called the static routing algorithm. It cannot adapt the situation. It cannot adapt the changes based on the situation. That is why it is called routing algorithm. Suppose there are suppose this is a host and this is a destination host. In between there are 1, 2 and 3 routers are there. So in the static, we already given the path to the static routers, that the path is one source to router 1 and then router 3. So this is already given. But if when packet is traveling through this route, if in this route there is a heavy traffic, so it cannot change the route to 2 to 3. Yes, it may possible that in this route the traffic is very less, because the route is already defined when the router is booted. So it cannot change the route even if traffic is more. So that is why it is called the static routing algorithms. Static routing is the simplest form of routing, but it is a manual process. It uses static routing when you have a very few devices to configure. If you have less than 5 devices, then you can add all the routing information manually. So then in that situation you can use this routing algorithms, and when you know the routers will never change the position, and the IP of the router will never change. In this situation only you can use these algorithms. Static routers are not fault tolerant. The lifetime of manually configured static route is infinite, and therefore static routers do not sense the recover from routers which are down. Suppose this router is down at this time when packet is reaches to this router. So at that time they are not fault tolerant. They can identify that this router is down, yes, but it cannot change the route. If this router is down, it can constantly running in on this route because this is not available here. So that is why the lifetime of manually configured static route is infinite. So that is the static routing algorithm is. Now next is advantages and disadvantages of this. So advantages are minimal CPU memory overhead, control on how traffic is routed, simple to configure and maintain, secure as only defined routers can be accessed, and bandwidth is not used for sending a routing update. So these are the benefits, and the disadvantages are manual update for router after changes, explicit addition of routers of all networks, and impractical on large networks. So these are the disadvantages of static routing algorithms. The second type is a dynamic routing algorithm. As the name suggests, this is all totally opposite of static routing algorithm. In this, it is able to adapt the situations based on the current circumstances. So a dynamic routing algorithm changes the routing decision if there is change in topology or traffic. If packet is traveled through a network, when the network changes, the topology of network is also changed. So at that time, it needs to change the routing path. So the dynamic routing algorithm do this task automatically. If traffic is increased in one route, then the dynamic routing algorithm is able to change the route on which traffic is very less. So each router continuously checks the network status by communicating with neighbors. Thus the change in the network topology is eventually propagated to all the routers, because all the routers are connected with each other and all transferring their information of neighbors. So that is why we can identify the network topology is changed or not, the traffic is occur or not. So based on the information gathered, each router computes the suitable path to the destination. So based on the gathered information from the neighbor router, it can choose the suitable path for the destination. So changes in the network topology are updated dynamically. So each router will select one or more best routes for each network destination to the router nodes. So here this is one router, this is one host, and this is one destination host. Now it has 1, 2, 3 different routers, same. The packet is traveled through this route. So first it reaches to the router 1, then after it reaches to the 2, and then it reaches to the destination. So now this is the common path, but at some time the traffic in this route is increasing, but at some time traffic in this route is increasing. So at that time dynamic or the adaptive algorithms get the information from this router that there is a heavy traffic in this route. So this router changed. So the routing algorithm is implemented on this router. So it make the decision to change the route. So it changed the route to router 3 and then reaches to the destination. So this is how the route is changed when some circumstances, some traffic or some topology change is detected. So dynamic routing protocol will then distribute this best route information to other routers running on the same running protocol. Now this router will send the information to other routers, so all the routers use the same best route. So dynamic routing algorithm gives the ability to adapt the logical network topology changes, equipment failures, or the network outage. So if some of the router is down, so in this situation, suppose this router gets down, yes, so at that time if they are traveling on this route, if this router is not working, so it can use this information and then adapt and then change the route and share this route information to all other connected in the network. So dynamic routing is fault tolerant, and this change can be propagated to other routers so that all the routers on the internetwork become aware of this new internetwork topology. So this is how the dynamic routing algorithm is worked. And if we compare these two algorithms, the dynamic routing algorithm is best when we want to send a message or we want to communicate over the internet or the network. Next are the advantages and disadvantages. So the advantages are simpler to configure on large networks, will dynamically choose the different or better route if link goes down, ability to load balance between multiple links. Yes, and the disadvantages are updates are shared between routers, thus the consuming bandwidth. Routing protocols put additional load on routers or the CPU or the RAM, and the choice of the best route is in the hands of routing protocol and not the network administrator. So that is all about the dynamic and static routing algorithms. So that's it. Thank you so much for listening.